My name is G.E.O., Research Associate at EnviroLab, and I'm here to tell you about the ClimActor package that was developed by EnviroLab. The ClimActor package was designed to simplify and streamline the data cleaning process when working with non-state climate commitments. As more non-state actors such as cities, companies, and regions commit to climate action, more initiatives and databases recording such climate action has also been more commonplace. Actors can commit to multiple initiatives, however, with slightly different names. On top of that, disparate actors can also have the same name. Two examples would be New York, which could refer to either New York City or the state of New York, or London, which can refer to London in Ontario or London in the UK. These discrepancies make data cleaning more difficult than it should be and can also result in overcounting of climate commitments if not accounted for properly. ClimActor package was designed to simplify these discrepancies and also to make the data cleaning process more manageable. On top of that, the ClimActor package also provides a contextual database including over 10,000 subnational actors committing to over a dozen climate initiatives. Information such as the population and the number of initiatives that each actor has committed to provides a snapshot of climate action taken by cities and regions globally. This video provides a short introduction to the package, and more details can be found within the package itself. Without further ado, let's get started. So to start using the package, you first need to install it from the GitHub, and you can do that using the install GitHub function within R in the DevTools package. And by default, this function does not include the vignette when you're installing the package. So it is recommended that you install the package together with the vignette, as the vignette provides a useful guide for using the package. And you can do that by setting the argument build vignettes equals to true in your install GitHub function. Subsequently, once you have installed the package, you can call it within your R session by using the library function. And in the future, if you would like to update your package version, you can run the install GitHub function again. Now that we have installed the package, we can start using it. And we start by reading in the data. The data that we're using today is the CDP cities emissions data, and this is readily available on the CDP website, and a link to it is also provided in the vignette. So within the ClimActor package, functions are grouped into different purposes or groups of functions, and we're going to start by talking about the data preparation functions. For cleaning data and using the ClimActor package, 3 different columns are the most important, and that is namely the actor name, the country that the actor resides in, and also the entity type of the actor, be it a city, region, or company. So the data preparation group of functions basically ensures that these columns are present in the dataset that you're cleaning and adds them if they're not present. So we can start by looking at the names of the different columns within the CDP data. And in this case, we know that the organization column refers to the actor names. And we can use the rename column function to rename the column name to one that's standardized for use within the ClimActor package. So right now we know that there is no entity type column within this data set yet, so we skip this part. And we can see that the column names of organization has been renamed to just name. So the next function that we want to use is the add country function to add a country column to the dataset. In this case, we notice that there is already a country column in the CDP dataset, and therefore the function will not add any additional columns. And last but not least, for the next column that we want to ensure is within the dataset is the entity type column. And since this is a CDP cities dataset, we add uniformly the entity type city to the dataset. And we can check that the column was added just by checking the last few columns of the dataset. And if you know that your dataset has neither the country or entity type columns, you can add them using just one function, which is the add country entity type function. And just for illustration's sake, I'll just demonstrate what that would do. In this case, both of these columns are already in the dataset, so no columns get added. Now, moving on to the next group of functions within the ClimActor package, we have the standardizing and pre-processing functions. So the previous group of functions ensure that the important columns are present within the dataset that we're cleaning, whereas this group of function ensures that there is meaningful and standardized data within those columns for further use. So before we dive deeper into the functions, it's also important to note that within the ClimActor package, there are several different data sets that you can use. And this includes two different key dictionaries. So one is the key dictionary for actors, and the other one is the country dictionary. These dictionaries provide a standardized version of an actor or country name and several alternative versions in which that name might appear under, and it's used to standardize the different names and country names within the data set that you're cleaning. So the first function that we're going to talk about here is the clean country ISO function. And before we begin, you could also create a vector of the original country names just for future reference in case you want to go back to it and refer to it. And the clean country ISO basically checks and matches for exact matches within the country dictionary that you supply. And in this case, we're using the ClimActor's country dictionary. And it also includes the 3 or 2 letter ISO depending on what the user inputs. So note that there is also an additional argument here called the cleanEnc argument. And this argument basically is for users to specify whether they are certain of the encoding that their dataset comes in. So for users who are not sure of the encoding of their dataset, they should set the cleanEnc function to false. And for users who know the encoding of the dataset, they should set that argument to true. And more details on encoding and how it relates to the ClimActor package can also be found in the appendix of the ClimActor package vignette. And after running the clean country ISO function, we see that there are 21 entries with no exact matches in the country dictionary. The function also outputs an index of which countries didn't match exactly in the country dictionary. And you can take a look at that using the index, and we see that the countries that didn't have an exact match was Taiwan and the Ivory Coast. Now we will circle back to these countries later on, but for now, let us move on to the next function. And the next function would be the fill type function. So recall previously that we set a uniform entity type of city for all the actors within this dataset. What fill type does is it looks for contextual clues within the actor names, looking at words such as city, town, municipality, to try and guess the entity type of the actor within the CDP dataset or within the dataset they're working with. So we note that after we use the fill type function, the entity types have changed a little bit, and we want to do a quick check for the entity types that got listed as companies, since we know that this is a subnational database. And we see that because of the word corporation, the entity type of the actor got listed as a company. In this case, it's important to do such checks because definitely the function is not 100% accurate. And in this case, we want to change the entity type back to cities for these actors. And after using a fill type function, there's also the resolve entity type functions, which checks the data set that you're working with a key dictionary that you're supplying. In this case, the inbuilt key dictionary of the ClimActor dataset, to try to resolve actors which have the same name and country, but different entity types between the user dataset and the key dictionary. So there are two options here, and we can start with you get to choose whether you want to accept the key dictionary's entity type, or if you want to do further checks on the data. So let's start with not accepting the key dictionary's entity type. and that outputs a data set of entity conflicts, which shows the different conflicts within the key dictionary and the data set that the user is cleaning. So we see that for some instances, the user has the entity type as region, whereas the key dictionary has it as a city. And in this case, we can accept all the different entity types within the key dictionary by inputting yes to this question. And now all the entity types in the user's dataset corresponds to the entity types found within the key dictionary. And then the next step would be to start looking at the the actor's names. And likewise, we can also create a vector of the original names for future reference. And the first step we take when looking at the actor's names is to remove certain extra words that we don't necessarily want. So like previously mentioned, words like city or town, now that we have figured out the entity types, we do not need these words anymore, and removing them would make the later cleaning process more efficient and easier. So we use the remove extra function to do that. And we can actually check for differences between the original names and the user's data set, the names with the removed words. And we see that over 700 actors have certain words removed, and we can compare some of these differences by looking at the difference between the original names and the CDP cities names. And we see that indeed words like city, prefectura, municipality got removed. So now that we have ensured that there is standardized information in the important columns, we can start cleaning and standardizing the actors' names using a group of string and phonetic functions within the ClimActor package. So we circle back to the country columns and start using fuzzy matching to ensure that all country names are cleaned. Since Clean Country ISO uses exact matching to standardize country names, there will be names where there is no exact match in the country dictionary supplied. So in that case, we use fuzzy string matching to search the country dictionary for close matches to the different country names that require standardization. And then we allow users to pick the standardized version of the country name that they're cleaning. So in this case, the original countries that were not clean was Taiwan and the Ivory Coast. And you can just input the number of the country name that matches with the country that you're cleaning. And in this case, we see that both cases, for both actors, there were a match in the country dictionary, even if it was not an exact match. And it's important to note that the fuzzify country function doesn't automatically add the ISO to the data set. So you see that the recently cleaned countries don't have the ISO information. So we just use the clean country ISO again to just include the ISO data back to the data set. And then subsequently, we can start cleaning the names of the actors. And we first start by using the clean name function, which searches for exact matches in the supplied key dictionary. And similarly, you can again create a vector of the pre-clean names just for further reference later on. And we see that from the clean name function, there is a new vector that was created called the name in, and these are basically the indices of the index of the names that didn't have an exact match in the key dictionary. And we can see some of the difference between the names that were cleaned and the names that were not cleaned. And then after using the clean name function, similarly, there will be names that there is no exact match in the key dictionary. And to standardize those names, we use the phonetify names to see which of these names correspond to a standardized version in the key dictionary and allow users to select for that when cleaning the data set. So the purpose of this function is similar to that of the fuzzify country function, except that it works on the name column instead of the country column. And apart from that, the algorithms used are also slightly different. The fuzzify country function uses fuzzy string matching that is based on string distances, whereas the phonetify names function uses phonetic matching, uses phonetic algorithms to decompose a word into its phonetic representations, and then matching different strings based on those phonetic representations. And this is largely due to the fact that there is a lot more actors and a lot more different versions of actor names as compared to countries. And we can start using this function to clean the different actor names. And users also have multiple options when doing the cleaning. So in this case, there is no match to the actor name that we're cleaning. So we can choose to type N to just select that there is no matches. And then in this case, we see that there is a close match for the name, and that would be the fourth entry. And we can input the number for that match. And then in this case, again, there is no match. And we will just do a few, we'll just clean a few names just so that we can get a sense of what the flow of this function is like. And in this case, we see that actually there is no exact match, but we can input a custom name. So if we just input the name Pereira, and once you are done cleaning, or after some cleaning, you can actually stop the function and go back to it subsequently to just key in as an option, and that will save the progress. And if you run phonetify names again, it will pick up where you left off and continue the cleaning where you left off. And once we have finished with, once we stop our progress using the function, you can actually see that there are a few more vectors that were created. So we have, for example, custom indices and unmatched indices. So these index are output so that users can go back and check on these different names since there was no match in the key dictionary. So if we look at the unmatched names, we see that there are we have selected a few that didn't get any matches, and we can also see the custom name that we had input for one of our actors. And these allow users to go back. These indexes allow users to go back and check on these names once they're done cleaning the names of their data set. So after going through the cleaning process, the package also provides certain post-processing functions that allow users to include contextual information in the dataset and to update the country or key dictionaries. So starting off, we have the contextualize data function, which allows users to merge in contextual data such as population, let law, all the different climate initiatives that the actor has committed to into the user's dataset. And along with the country and key dictionaries provided in the ClimActor package, there also is a subnationals contextual database that is named contextuals in the package, which has over 10,000 actors and has these different contextual information that we mentioned previously. So we can use the contextuals database provided with the package to illustrate the example of contextualized data. And in this case, we just want to merge in the initiatives committed and the number of commitments that the actor has committed to. And once we're done with the merging, we can actually take a look at the data. And we see that the initiatives committed and the number committed of the number of climate initiatives that the actor has committed to has been added to the data set. But of course, there are certain actors that might not be in the data set as well, that has no contextuals data in the contextuals database. Apart from merging in the contextuals data for the user's data set, there are also functions that allows users to update the key dictionary and the country dictionary, and they can export these dictionaries as a local copy to use in the future when they're cleaning subsequent data sets. So we can first update the country dictionary. And let's take a look at the newly added entries. And we can see that Taiwan, for example, has been updated and added to this new country dictionaries, which users can then export and save and use next time when they're cleaning other data sets. And so, likewise, we can do that for the key dictionary. And once we export a local, and once we update a local copy of the key dictionary, we can see that the different phonetic algorithms have also been included for the new actors that were added. So we see that for actors that got a match during the cleaning process, the match name is added under the right column, whereas for actors that were unmatched or were provided custom names, the right column returns an NA, and users can choose to update the right column with the unmatched or the custom names themselves and export that as a local version of their key dictionary. Users can also opt to send these updated dictionaries to the data-driven EnviroLab, and the lab will periodically review these updates and update the package with updated and more comprehensive versions of the key dictionary. For any such updates and any queries that they have about the package, they can email them to the email address that is going to be shown on the screen. And with that, we've come to an end of the data cleaning process. And please do feel free to reach out if you have any other questions about the package. Thank you.